For question 1, part A and B, you actually don't need the calculator for those parts. So to answer part A, is it growth or decay, we have to look at the number that's connected to the exponent. In this case it's a t, other times it could be an x. But since that number right there is bigger than 1, even though it's just a little bit bigger, this is exponential growth. The initial deposit, how much money there was at the beginning, is always the very first number, the one that isn't connected to the exponent. So in this case, there would be $300 when the bank account was first opened. For part C and D, you do need the calculator. So on your calculator, you'd go to y equals and type in the equation, 300 times 1.005 to the x, make sure you put caret x, and then you'd press second graph and scroll down on the table until you see 21 years. Right next to that in the table, so here's the x column, here's the y. At 21 years, there's $333.13. Part D, would this be a wise way to grow your money? Well, considering after 21 years you've only made $33.13, I would say no, not really, because the money doesn't grow that fast. It's your opinion, you just need to write down what you think and back it up. For number 2, you need to go to y equals, type that equation in exactly as you see it, and then copy down the numbers next to -2, -1, 0, 1, 2, and 3. So it looks like the numbers will go like this, 24, 48, and then 96. So you'll take those and you need to plot them as ordered pairs on the graph. I'm going to make the x scale go by ones, 1, 2, 3, and then because we need to get up to 96, I'm going to count by tens, 10 on the y, 20, 30, 40, 50, 60, 70, 80, 90. If you counted by something different, that's fine. So I'm going to go ahead and plot -2, 3. That's the ordered pair. 2 back, 3 up. -1, 6. 0, 12. 1, 24. 2, 48. And 3, 96. So I know these aren't perfect, but if you just throw a random line on your graph, you're not going to get points for this question. I need to see that you're actually plotting the ordered pairs from the table and then connecting them with a line. Alright, in order to make this into one single logarithm, we are going to combine the log 6's because they're both the same base, and whenever we see an addition problem, we are going to multiply the big numbers. So we need to multiply 72 by 2, and it will become log base 6 of 144. So we did the first part, now it says simplify. Well, 6 to what power equals 144? If you can't figure it out, you could type math alpha math on your calculator, or you could take the log of 144 and divide it by the log of 6. You'll get a decimal. It's about 2.7. For number 4, it says express this as a product because the first thing you have to do is take that 5 that's the exponent and move it out front. So this problem becomes 5 times log base 4 of 16. Now our job is to simplify the blue part. What we're really thinking over here to the side is 4 to what power gives us 16? Well, maybe you can look at that and figure out the answer. You could start trying 4 caret 1, 4 caret 2. It turns out 2. 2 is the answer. 4 squared equals 16. So we have 5, because that comes from the exponent, times 2, and our final answer is 10. Number 5, my advice, start doing 5 caret on your calculator and see when you get 625. And it turns out 5 caret 4 equals 625, so the answer here is 4. You could also type that in math, alpha math, and type it in just how you see it, and it will give you 4 for the answer. Alright, number 6, we have to take this and put it in log form. If you remember, excuse you, Lindy, if you remember, log base b of the answer equals the exponent. So I'm going to label all the parts of this. 9 is the base, 2 is the exponent, and 81 is the answer. So let's just rewrite it. Log of the base, which is 9, of the answer, 81, equals the exponent, which is 2. So that's the answer to number 6. Number 7, you could type in the calculator, or you could try 3 to what power equals 81. Well, start trying the carets, and it turns out x equals 4. Lindy agrees. 3 to the 4th power equals 81. Now number 8, we could try to do the same way. We could try to figure out 36 to what power equals 216. This one isn't so easy to get the answer. See how it says round to the nearest tenth? That means our answer is going to be a decimal. So we could do this 2 ways. We can press math, alpha math. Or if you don't have a calculator at home and you're trying this, you can do log of 216 and divide it by log of 36. If you do it that way, your answer will be 1.5. Number 9, we need to do the same thing we did up in number 6. We need to write log of the base, which is 6, of the answer, which is 216, equals the exponent, which is 3. How do you check it? 6 to the 3rd power equals 216. For number 10, we're going to go the other way. So I'm just going to label this. I know 2 is the base, I know 1/4 is the answer, and logs equal exponents. So the negative 2 is the x. So we're going to write it in the form b to the x equals the answer. So this becomes 2 to the negative 2 equals 1/4. That's the answer. Alright, for number 11, we want to combine these two logs that are both log 7, and the rule, since it's a subtraction problem, is to divide those two. So off to the side here, it's x to the 3rd divided by x to the 1st. 3 minus 1 is 2. So this becomes log base 7 of x squared, and that equals 2. So we'll rewrite it in exponential form. 7 to the 2nd power equals x squared. 7 to the 2nd equals x squared. So if we kept going, we could say 49 equals x squared, and square root both sides, and you'd get x equals 7. Alright, the last few problems. If the 8 and the 4 were the same number, we would be allowed to set the exponents equal to each other, but they're not quite yet. So we're going to rewrite both of them. I know Lindy doesn't like that idea. 2 to the 2nd power is 4, but we can't forget that we have that x next to it. So it's 2 to the 2x. That will equal, well, we can rewrite 8 also using a base 2. 2 to the 3rd power is 8. And then we can't forget we have that x plus 2 next to it. Now that the bases are the same, now we can set these exponents equal to each other. When I do that, I'm going to distribute the 3. So it's 3 times x, 3x, plus 3 times 2, so plus 6, equals 2x. That's a 6. So let's just get the x's on the same side. I'm going to minus 3x from that side. And 6 equals negative 1x. And when I divide both sides by negative 1, I get x equals negative 6. The same plan we'll use for number 13. 2 looks good. 2 to the x minus 8. I'm going to leave it. We need to rewrite the 32 using a base 2. It turns out 2 caret 5 is 32. But don't forget, you have that little x next to it. And so now we're going to set those exponents equal. So the equation is x minus 8 equals 5x. So now we solve this for x. We'll minus 1x from both sides. And we get negative 8 equals 4x. And when you divide both sides by 4, you get x equals negative 2. That's the answer for 13. On number 14, we have a 3 for a base right here. Let's try writing 6561 with a base 3. We can do that. It's 3 to the 8th. So now that we have the same base, we can set the exponents equal to each other. 2x equals 8. And when we divide by 2, we get x equals 4. Very last one, we have 5 for a base. We want to try to write 100 with a base 5. Unfortunately, we can't do that. So we're going to take the log of both sides. That allows us to take that exponent and bring it out front. So it's 2x times log 5 equals log 100. So let's solve this thing for x. We need to get rid of the log 5, so we're going to divide by log 5. Gone. And we divide the other side by log 5. So we're left with 2x equals, when you type log 100 divided by log 5 in your calculator, don't forget to close the parenthesis after the 100. You get 2.86, and then when you divide both sides by 2, your answer is 1.43. Done. Good luck studying. Good luck on the test tomorrow. I think you will do wonderful.